Good morning, everybody. This is the notes for Calculus, Section 3.1. We're actually starting Calculus type material. So, the first thing we got to talk about is this idea called limits. It leads into what the definition of a derivative is. So, a limit, the simple definition, like it says in orange, the limit of a function is what the y value approaches as the x values get close to a number. Now, I want you to copy down this actual definition that's in black here because there's some things to the detail of this definition so that we can be accurate with finding the limits. But again, the main idea is what are the y values getting close to as the x values get close to a number. So the limit, it's a y value if the limit exists. So in the definition, it says let f be a function and let a and L be real numbers. So we just got some values. If, number one, as x takes values closer but not equal to a, so we're approaching the number a, which is an x value, but we're approaching it from both sides of a. So coming from the left, moving towards that x value, and coming from the right, moving towards that value, towards that x value. The corresponding values of f of x, which f of x is just a y value, the corresponding y values get closer, and sometimes they'll equal this value of L. So it's the x values are approaching a number from both sides. The y values are getting closer to a certain value, L. And second part of the definition, the value of f of x, the y value, can be made as close to L as desires by taking values of x close enough to that number a. So what we're looking at, that's our definition. This is how we write this. The limit of the function f of x as x approaches a, the limit equals L. So for example, we would be looking at the limit of a function as x approaches 2 is 7, something like that, okay? So what that statement that I just wrote would mean is as the x values get closer to 2, the y values are getting closer to 7, all right? So that's what we're talking about. Now, a couple other little details. Because in order for a limit to exist, we have to be approaching an x value from both sides. Sometimes we just talk about from one side or from the other side. So what we're looking at is this little detail right here and this one here. Okay, the limit of f of x as x approaches a. If there's a little negative sign in the exponent position, it has nothing to do with the exponents, it's just where we write it. With that little negative, that means we are approaching from the left. So if you think about your x-axis, from the left, we're coming from the negative side, moving towards that x value of a. If there is this plus in that exponent position, that means we're approaching the x value of a from the right side. So coming from the positive, moving towards the x value. All right, so now a couple of other little details. And it's kind of an easy topic, but there are just these little details that you guys got to be taken into account. So two of these things. The limit, that y value, it's not affected by whether or how f of a is defined. You may have a graph where the function does not exist at that x value, all right? But the y values are still approaching a number. So it doesn't matter if the function is defined there or not, the y values are still approaching a value as x approaches a. The definition applies the function cannot approach two different values, okay? We have to be approaching the same y value from both sides. So if you had a graph that was like this, where there was an open circle here, and then a closed circle here, at this x value of a, here's our y-axis, as the x values approach from the left, that's this part of the graph, we're going towards a certain y value. Let's call this a y value of 2. As the x values approach a from the right, our y values are approaching 1. So we're approaching the x value of a from both sides, but we're going to different y values. This limit would not exist. DNE does not exist. We have to be approaching the same y value from both sides. All right, so what we're talking about in this first section is really just looking at tables, as you see a couple of them here, and looking at the graphs. And we'll talk about the graphs here in a second. So, for number 17, this top one, you're given this function k. It's a rational function. But the question is, find the limit of this function k as x approaches 2. So we're looking at the x values. They are getting very, very close to 2 from both sides. So when you look at this x values going across here, we're getting closer to 2 in both, or from both directions. So the question is, what's the limit of this function? The answer is, what are the y values approaching as x gets closer to 2? So when you look at these y values, they are getting closer and closer to what looks to be 10, but it's got to be approaching the same y value from both sides. So 10.61, 10.0601, 10.0061, it's getting closer to 10. So the answer to this one would be 10. So the limit of function k as x approaches 2 is 10. The y values are getting closer to 10 as x values get closer to 2. All right, looking at this bottom example, again, all I did was I just typed this equation into a calculator, went to trace, and figured out these y values from the given x values. So the limit of this function as x approaches 1, so as we move closer to an x value of 1, these y values are getting, well, they're just getting larger. As we go towards 1 from the other direction, from the right, x values are getting closer to 1, but these y values are getting really large, but negative. So are we approaching the same y value from both sides as x gets closer to 1? No, we're going to positive 1,000 from the left, negative 1,000 from the right. That limit does not exist. Okay, we got to be approaching the same y value from both sides. Just want to make sure I'm still recording this. All right, good. So let's go to the next slide. Okay, so hit pause, take a second to look at all this stuff in this graph, and there's a ton of stuff. I don't even know if this function could exist, but there's a ton of stuff in this graph. So we have a vertical asymptote at an x value of -6. We have a separation in the graph here at this x value of -4. We have an undefined value here, but the function is defined at an x value 0. It's defined right here, but it's undefined on this part of the graph. We have another vertical asymptote at x equals 3. We have this other hole in the graph here at an x value of 4. Okay, there's a ton of stuff in this graph. So, details. So just to find the following values, I'm starting right here. F of -4. So what is the y value when x is -4? So at this x value of -4, it's undefined right here. It's got the closed circle here. That's at a y value of 2. Okay, f of 0, that's this spot right here. Okay, it's undefined up here at a y value of 3.5, but it is defined at at a y value of 2. F of 6, we'll go over this x value of 6, it is at a y value of 2. F of 4. At f of 4, when we plug in an x value of 4, we're looking at this open circle right here. Open circle, the function doesn't exist there. That hole is at the point 4, 1, but the y value doesn't exist there. That's the open circle. So what is f of 4? Does not exist. Okay, the y value is just, it's undefined there. It's called a hole in the graph, or a removable discontinuity. All right, so I know this is kind of hard to see, but there is a negative right there. I couldn't get this to appear any better. So the first limit is, what is the limit of this function f as x approaches -4 from the left side. All right, so we're looking at an x value of -4, but we're coming from the left. So as these x values get closer to -4, we're looking at what are the y values doing. They're getting closer and closer to this point, which is at a y value of 2. All right, the next limit moving across, the limit of the function as x approaches -4 from the right. So now we're coming this direction. I'm going to use a blue marker here. We're coming from the positive side, moving towards an x value of -4. This y value is getting closer to, looks like 3. All right, now the next question is, what is the limit of the function as x approaches -4? Remember, part of the definition is, as the x values approach a number, for the limit to exist, it's got to be approaching the same number from both sides of that x value. So as we approached -4 from the left, our y values went to 2. As we approached -4 from the right, our y values went to 3. So this limit does not exist because we're approaching different y values from either side of that x value. Okay? We can have these individual one-sided limits, but the limit as x approaches -4, because it's approaching different numbers from different sides, the overall limit does not exist. Okay, so video is getting a little bit lengthy here, so I want you to try the rest of these. Figure out these limits, and we'll talk about it in class. There's another little thing to talk about. I'll move the slide, maybe. What just happened here? Technology, it's awesome. Take a look at these. You don't need to copy all these down, but take a look at these. We'll talk about them. Just hit pause and just kind of glance over. Try to make sense of what there is. There's a lot of math jargon in here, but we'll talk about it. That's all. Have a great night.